Now that we have a good understanding of spanning tree algorithm, let's take a look at an example and see if we can figure it out. Go ahead and pause your video and see if you can figure it out, and then we'll go over it together. All right, hopefully you've had a chance to figure this out. Let's go over it together and see how well we did. So first step is to find out what the root bridge is. We need to elect a root bridge. The root bridge is based off of whichever is the lowest bridge ID. The bridge ID is a combination of the priority plus the extended system ID plus the MAC address. And so we take a look at the priorities and we can see that two of these are default priorities, while one of these is 36,864. The default priority is 32,768. So both these defaults are 32,768. So we know that this switch 3 is not going to be a root bridge. It's going to be one of the other two. And we know that the priority is the same on switch 1 and switch 2, so we have to look at the MAC address. And in the MAC address, we start to see that this starts with a 1 versus this other one starts with a 0. So we're going to prefer the one that starts with a 0 because it's a lower number. So therefore, this switch 2 will be the root bridge. So switch 2 is the root bridge. Next, let's go ahead and calculate the root path cost. And we got to do that for every switch link. So switch 2 is our root bridge. Let's take a look at switch 1, which has 4 connections going out. And we can see that the cost that goes to the root bridge from this first one is going to be 19. I look at this, this is 100 megabits per second, and 100 megabits per second means that we're at a cost of 19. So that's 19. This next one is the same one, so this is 19 as well. The gigabit per second connections are at 4, so these are 4 plus whatever it takes to get across here. So this switch 3 also has a cost of 4 for each of these. So total, each of these links are actually going to be 8 to get to the root bridge. All right. So, and then we can, once again, yeah, these are both 4 right there. All right, so that is the root path cost for each one of these. The next one is we need to elect root ports. So we take a look at this and we say, well, these two on switch 1 are not going to be root ports. So it's got to be one of these other two, 046 or 45. And so if they are the same cost, which they are, then we look at what the port ID, the sending port ID is. So we see 047 and 048. So it's going to be 047, the lowest, if there's no priority set. So we don't see that there's any priority listed, so we're going to assume that it's the default priority. So this first one, 045, is actually going to be the root port. And we do the same process on switch 3. So switch 3, we can see that this is 45 right here versus 46. So this is going to be the root port is going to be 045 on switch 3. So there we have it. Okay. So now we figured out the root ports. Now we got to figure out designated ports. The designated ports are going to be whatever's closest to the root bridge. So obviously these ports on the root bridge are the closest. So those are all designated ports. And then we will see on switch 3, we've got a designated ports on both these links right here. And so let's see, does all the links accounted for? This link has a a designated port here. This link has a designated port. This link has a designated port. This link has a designated port. This one and this one. Okay, so we've got every link has a designated port. Now we need to elect the alternate ports, the ones that we're going to block. So this is the 045 is the root port for switch 3. So now we're going to block 046 because that is an alternate. So let's mark that as an alternate, so that put an A right there. And then these other two ports on switch 3 are designated ports already. So then on switch 1, we can see that 046 is going to be the alternate. So we'll make that, mark that as A, and then also 43 and 44 are redundant links also, so we need to make both those alternates. So there we have it. Now we have elected the designated ports and elected the alternate ports, and we have finished this problem.